Welcome to Bright Bounds. Welcome to Bright Bounds, where we explore the most extraordinary phenomena happening beyond our planet. I'm your host, and today we're investigating something that has the scientific community absolutely captivated. A visitor from the depths of interstellar space that shouldn't exist the way it does. Imagine an object traveling faster than anything we've ever recorded in our solar system, approaching from a direction that violates our understanding of probability, and behaving in ways that completely defy our expectations. What is it? Where did it come from? And more importantly, what does its presence tell us about the universe we thought we understood? This is the story of 3I Atlas, and trust me, it gets weirder than you could possibly imagine. Stay with us as we unravel this cosmic mystery. On July 1st, 2025, astronomers monitoring the night sky through the Atlas telescope network positioned strategically across Hawaii, Chile, and South Africa detected something unusual. It appeared as just another asteroid, one of thousands that drift through our solar system in ordinary trajectories. But within hours, something became abundantly clear. This object was different. The initial hypothesis suggested routine orbital mechanics. Instead, researchers discovered that 3I Atlas was traveling at 58 kilometers per second, making it the fastest moving object ever detected within our solar system. To put this into perspective, Earth orbits the Sun at a leisurely 30 kilometers per second, while Mercury, being closer to the Sun's gravitational well, must accelerate to approximately 48 kilometers per second to maintain its orbit. At such velocity, combined with its position near Jupiter's orbit at 4.5 astronomical units from the Sun, this object possessed sufficient energy to completely escape our star's gravitational influence. It wasn't trapped. It wasn't ours. This was something visiting from elsewhere. The designation came swiftly. 3 Atlas III confirmed the interstellar object ever detected. The other two, Oumuamua and comet Borisov, had already provided hints that other star systems existed beyond our understanding. But 3I Atlas was about to prove that we knew even less than we thought. Before 3I Atlas ever graced our telescopes, it had been wandering through the cosmos for an incomprehensibly long time. Astronomical research traced its trajectory backward across 10 million years, identifying 93 stars it would have encountered during that journey. The closest approach to any of those stars, a mere 0.3 light years, approximately 63,000 astronomical units. By comparison, its current proximity to our Sun is just 1.4 astronomical units. In other words, by cosmic standards, it practically grazed our star. But here's where it becomes truly extraordinary. Astronomers estimate that 3I Atlas originated in the galactic thick disk, an ancient, sparsely populated region surrounding the Milky Way's core, where stellar objects remain largely undisturbed. This suggests 3I Atlas could be as old as 7.6 billion years, nearly twice the age of Earth itself. This isn't a recently expelled planetary body. This is a relic from the universe's formative epoch, drifting through the cosmic ocean for billions of years before stumbling upon our solar system. What does this object carry with it? What secrets from its ancient origin have survived this extraordinary journey? Probability suggests that interstellar objects approaching our solar system should arrive from the direction our Sun is traveling through the galaxy, a head-on collision. Metaphorically speaking, the first to confirm the interstellar visitors, Oumuamua and comet Borisov, followed this predictable pattern. 3I Atlas does not. Instead, it arrived from the galactic core region, striking our solar system in what can only be described as a T-bone collision. More remarkably, its trajectory aligns with the solar system's ecliptic plane, a flat disk, where virtually all planetary bodies orbit at merely 3 degrees of deviation. Consider this: space is three-dimensional. An object could approach from any conceivable angle across an infinite spectrum of possibilities. Yet 3I Atlas arrived in near-perfect alignment with our planetary disk. The statistical improbability of this occurrence is staggering. Astronomers recognize this as either extraordinary fortune or an indication that we're missing critical pieces of information about how interstellar objects navigate the galaxy. The objects emerge from the direction of our galaxy's dense core region, so crowded with stars that their gravitational interaction create a fundamentally different cosmic environment than our quiet neighborhood. What gravitational forces? What stellar encounters? What cosmic architecture guided this ancient object to intersect with the world at precisely this angle? When the Transiting Exoplanet Survey satellite tests first captured images of 3I Atlas on May 7, 2025, astronomers expected to observe a gradually brightening object as it approached the Sun. The mathematics were simple: get closer, receive more light, appear brighter. The reality shocked them. The flux of perceived brightness increased by a factor of 5 rather than the predicted 1.5. This dramatic luminosity surge signaled the formation of a coma, the characteristic cloud of gas and dust surrounding a comet. But the timing was catastrophically wrong. 3I Atlas was still beyond Jupiter's orbit, traveling through regions so frigid that comets traditionally remain frozen, inactive, and invisible. The reason for this aberration revealed itself through spectroscopic analysis. 3I Atlas isn't primarily composed of water ice like conventional comets. It's dominated by frozen carbon dioxide. Dry as solid CO sublimes at dramatically lower temperatures than water ice. While our solar system's comets require significant solar heating to activate, 3I Atlas began releasing its gaseous envelope from an extraordinary distance. As it approached the Sun, the composition ratio transformed. By late September, as the object passed through Mars's orbit at 1.5 astronomical units, water vapor erupted from the nucleus in quantities unprecedented for that distance, equivalent to a fire hose at full capacity. This compositional transformation wasn't gradual. It was abrupt, violent. We've never witnessed such a sudden aqueous release in any documented comet. Perhaps the most perplexing discovery involved the metallic composition of 3I Atlas's coma. During early observations, astronomers detected nickel, but absolutely no iron. This creates a genuine scientific paradox. Nickel and iron form together in stellar cores. When stars explode as supernova, they distribute these elements across space in similar quantities. They're incorporated together into new planetary systems. They should always appear together. Yet 3I Atlas showed nickel without iron, a chemical aberration that demands explanation. The leading hypothesis suggests that the violent sublimation of CO gas physically drags nickel atoms outward with such force that they become visible before iron can join the process. But this explanation, while plausible, leaves physicists unsatisfied. Something separated these elements. Something in 3I Atlas's history or composition created this unusual distribution. Then, remarkably, as the object continued toward the Sun in late September, iron finally appeared in spectroscopic readings. The nickel-to-iron ratio normalized to expected proportions. The object began revealing its true chemical character, but only gradually, reluctantly, as if shedding layers of disguise as solar heating intensified. What process created this delay? What kept iron hidden until the precise moment when sublimation reached critical intensity? The answers remain tantalizingly out of reach. Every schoolchild learns that cometary trails point away from the Sun, pushed by the solar wind into an elegant streaming configuration. This is physics. This is fundamental. 3I Atlas initially ignored this fundamental principle. When astronomers first observed the tail forming during the summer, it pointed toward the Sun rather than away from it. This isn't merely unusual. It challenges our comprehension of solar wind dynamics. The solar wind represents a constant stream of plasma and particles emanating from the Sun's surface. It's bending outward in all directions. It should push coma particles exclusively away from the star. The explanation, while intriguing, remains speculative. The extreme distance and the early formation of 3I Atlas's coma driven by COA's low sublimation temperature may have preceded the solar wind with sufficient intensity at that distance. The coma accumulated on the sun-facing side before encountering winds powerful enough to redirect it into a conventional configuration. By September, this behavior corrected itself. A short, fan-shaped tail developed, pointing away from the sun as expected. But this reversion to normality raises profound questions. For how long did this object behave according to one set of physical laws before suddenly conforming to another? What defines the transition point? While Earth-based observations provide essential data, the most intimate photographic evidence came from an unexpected source, Mars. On October 3, 2025, 3I Atlas passed within 0.19 astronomical units of Mars, the closest approach to any planet in our solar system during its current trajectory. This proximity, combined with the extensive camera infrastructure orbiting and exploring the red planet, provided an extraordinary opportunity. The Perseverance rover captured images of 3I Atlas streaking across the Martian sky. The resulting photographs, while not dramatically detailed, required 30-second exposures and multiple image stacking to render visible. What appeared was more streak than discrete object, a luminous smear across the cosmic background. The European Space Agency's ExoMars orbiter provided clearer imagery, revealing the coma structure more distinctly. Yet even this advanced optics couldn't resolve sufficient detail to separate the bright coma from the solid nucleus itself. NASA's Mars Reconnaissance Orbiter possesses the most sophisticated telescope system in the Mars environment. Its imagery would have provided unprecedented resolution and detail. However, due to a US government shutdown at the time of the observation, this crucial data remains potentially uncaptured, a frustrating reminder that even cosmic events must navigate human bureaucracy. As 3I Atlas approaches perihelion on October 29, at one point for astronomical units just inside Mars's orbit, the sun's glare completely obscures our view. We cannot directly observe the climactic moment when solar heating reaches maximum intensity. Instead, we wait through December, when the object emerges on the opposite side of the sun for continued study. The next significant observation opportunity arrives on March 16, 2026, when 3I Atlas passes within 0.36 astronomical units of Jupiter. The Juno probe, having spent a decade studying the gas giant, will capture potentially the final detailed images before this ancient traveler departs our solar system permanently, returning to the interstellar void. But here's what fundamentally changes our perspective. The bizarre characteristics we've observed in 3I Atlas might not originate from its formation in a distant star system. Instead, they might represent accumulated modifications, evolutionary adaptations acquired during its billion-year journey through interstellar space. Cosmic radiation, gravitational encounters, thermal cycling across the void, impacts from interstellar dust and particles. All these forces slowly transform any celestial object. 3I Atlas might be less a pristine sample from another star system, and more a weathered relic bearing the scars of cosmic experience. This realization fundamentally reshapes how we interpret interstellar objects. Each visitor from beyond carries not just information about its origin, but also the story of its journey. Each anomaly we detect might indicate previous encounters, previous transformations, previous near misses with other stars. The universe communicates through these messengers, and we're only beginning to learn the language. This cosmic mystery continues to unfold in real time. No observations arrive constantly. No analyzers challenge previous assumptions. The scientific community remains in a state of creative uncertainty, and that uncertainty drives discovery. You've just witnessed the convergence of billion-year timescales with immediate observation history unfolding before modern instruments. If this investigation into 3I Atlas has captivated your imagination, if you're curious about what else the universe contains beyond our conventional understanding, then I encourage you to join our community at Bright Bounds. Like this video if you found value in exploring this cosmic enigma. The algorithm reward engagement, and your support directly enables us to investigate more extraordinary phenomena. Share this with others who appreciate deep cosmic mysteries, who wonder about the universe beyond textbooks, who understand that reality often exceeds imagination. Subscribe to Bright Bounds and activate notifications. Future episodes will explore phenomena equally astounding, from gravitational waves and black hole dynamics to exoplanet discoveries and the fundamental architecture of reality itself.